Okay, let's see how this goes. Okay, I have to keep pushing that over because actually that's pretty good. There's still some metal in there still as against the aluminium, but okay, that one went pretty well, I think. And so let's try this next one here. Start off in the middle. Looks like I've gone off a little bit. Yeah. Okay, let's try this next one. I think I might try a wooden block. See how that goes. That's good. That went right in the middle. A bit annoyed about that one going off on an angle, but anyway. And last one. that went well too, right through the middle. So 3 out of 4, bugger that. Yeah, you can see the drill's just gone, started right in the middle here, but it worked its way off the steel and off at an angle. I mean, well, I don't think that's such a big deal. The off is on this side. We'll just, it can be an elongated hole from here, as long as we've got a nice straight hole there. And also, if necessary, I can fill that with aluminium weld if necessary, but I don't think I need to go that far. Okay, so let's get the rubbish out of those and see where that takes. Alright, and that just fell out, as you can see there. Alright, so that's most of that cleaned up. What I'll do is just deburr those edges, just to clean them up a bit, and leave it at that for the moment until I can decide. Okay, carrying on the saga from yesterday, these here are the points, and of course all the books say that that's the thing that needs cleaning the most. So the points are right in there, like contact points on a distributor, same thing. And I've been cleaning that, so rather than bore you with the detail, I managed to separate. Gee, it's under a lot of spring tension, but so I put this parallel punch in between just to open the contacts, and been using some 320 grit, wet and dry, and then scrubbing it in between the points like so. I hope you can see that. There, let's see how that goes. That's just on ohms resistance, and if I connect it between these 2 points here, I should show a very low reading, and I do 0.6 ohms. Let me see, can you see that? Yeah, okay, down to 0.3. Okay, so if I break those contacts, again, it's a little bit awkward, I should come to a high resistance. Yep, which is, as you can see, it's around 60 kilo ohms, and then let break it again, and boom, it's okay, let me try that again. Probably means they're not clean enough. Okay, and break again. Connection 0.6 ohms, yeah, and again break the contact. You can see there about 70 odd kilo ohms, and down to 0.5. So I'll just clean that a little bit more with that that 320 grit. And the other thing is, I need to check the coil windings, and they go from about here to about the other side of the coil. Is, I think, right there, and I'm reading about 1.1 ohms. So to me that's good. It should be low, because I understand that these draw a hell of a lot of current, and because of that the resistance would be very low. So to me the coil seems to be okay. So if I take a look at that now, between that and earth, okay, so I'm reading quite a high reading of over 200 kilo ohms. And now, very interestingly, this is the capacitor, this thing that sits vertically down. Again, see if you can see that. Yeah, right there. And I'll set this to capacitance readings, and again read one end to the other, and I'm reading about 74 nanofarads. Now the book says that these were later replaced by about 25 microfarads, so I'm a little bit confused about that. Either I'm not reading this correctly. Okay, so again, about 74 nanofarads, and it's a fluke tester, so it's pretty straightforward. And let me just see. 74 nanofarads. Let's see if make sure that's earthed out. I don't think it's electrolytic for nano. That certainly wouldn't be electrolytic. Not that I'm an expert on capacitors. Okay, so we take a reading again, and you can see it jumps pretty well straight up to 74 nanofarads. So I'm assuming that the condenser capacitor is okay. So it tells me that, from what I read, that everything is essentially okay with this electrically. So what I can do is just close that up a bit more, and so seal that up. I'll reassemble that, and get it ready for a little paint job. Okay, so this is 16 gauge aluminium, and the depth of my cover plate is 12 mil, but if I look at the inside, it's about 9.5, so I'm going to make it 10.5, and so mark that up. And the next job will be to guillotine that off. So I'll turn the camera around so you can see what's happening. Okay, and then we have this guillotine here, which has now been marked up. And let's have a look and see how that went. Okay, so you can see that this will be the side edge, like so. Okay, and it's telling me that the circumference of that is about 410 millimeters, so I might need two strips of that. And yes, that'll make two of these things. Okay.